Welcome to Chem Activity 4I. This is the last of our activities in which we're going to learn how to name different kinds of compounds. There are, of course, lots of other kinds of compounds that chemists learn how to name, but in Chem 111, this is our last little bit. And in this activity, we're going to concentrate on learning how to name acids. Now, it turns out that in chemistry, there are several different ways that we're going to define an acid, but for the purposes of Chem 111, we're going to identify an acid as a compound that combines H+ ions with some anion. And that anion could be a simple anion like Cl- or a polyatomic anion like nitrate. And the acids we're going to consider are the ones that dissociate in solution like an ionic compound. So based on this little bit of information, how can we identify an acid by looking at its formula? What will be present? Well, that means that we're going to see an H+ ion and some anion. So it could be like HCl or HNO3, or it could be something like H2SO4. So it can have more than one H+. As the model said, we're going to consider acids that dissociate in solution like an ionic compound. And those are going to be our strong acids. So go back to Chem Activity 6b, find the page that has the list of strong acids, pause the video so you can go find them, and write them in here. And here they are: HCl, HBr, HI, HNO3, H2SO4, and HClO3. And just to be complete, let's ask, what do the ions of a strong acid do in solution? Well, they dissociate. I don't know why my eyes won't dot there, but they won't. So for example, if we have something like HNO3, they are going to dissociate in solution into H+ aqueous plus NO3- aqueous. So here's another example of where you need to be able to look at something, pull out the polyatomic ion, and know what its formula and its charge are. All right, so now that we know what we're looking at when we see an acid, now we need to learn how to name it. So the most important thing to recognize is that the naming convention is going to depend on the type of anion that's present. So if the compound is a binary acid, meaning H+ plus some sort of simple anion, then what's going to happen is the word hydrogen is going to be changed to the prefix hydro, and the other non-metallic element, in other words, the thing that's the simple anion, is going to get modified by adding the suffix -ic, and then we just add acid at the end. So for example, here's HCl. We're going to change the word hydrogen to hydro, and we're going to change chloride to chloric. So there's that suffix -ic. So for something like HF, we can recognize that it is a simple anion in there. That means we can use this set of naming rules, and we're going to get hydrofluoric, that's a UO, acid. One thing that somebody taught me a long time ago is to remember that fluoric is spelled the opposite of flour, as in like the flour that you put in bread, and the U comes first, and so you owe it to yourself to spell fluoro or fluoride correctly, or fluorine. So similarly, if we look at HBr, we recognize that that contains the bromide ion. So again, that means we can use this set of naming rules. And so this is going to be hydrobromic acid. Oops. And finally, in this set of examples, we've got H2S. That means we've got S2- in our acid. This is still a simple anion. In other words, it's one atom that has gained some electrons. So that means we can still use this naming convention. And so that's going to put hydro at the front. hydrosulfuric acid. Now, the previous page we learned how to name acids that had simple anions. There's another class of anions that we need to be able to deal with, and those are called, the class of acids are called oxyacids, and they are comprised of H plus as your cation and an oxygen-containing polyatomic anion. So for example, something like NO3 minus is an oxygen-containing polyatomic anion. Something like SO4 2 minus sulfate is an oxygen-containing polyatomic anion. So if we combine these with H+, we're going to get what are called oxyacids. Now, how do we name it? So first of all, the name does not explicitly name the hydrogen at all. So unlike in the previous examples where we were looking at like hydro something, we're just not going to name the hydrogen at all. The name itself is based on the name of the anion, changing the suffix according to these rules. If the anion name ends in ATE, then the suffix gets changed to IC. If it ends in ITE, it gets changed to OUS. And then we just add the word acid at the end. Here's some examples. Now, one of the things you'll see in this table is that there's some examples of ions that you have not memorized. They go outside that list of the polyatomic ions I asked you to memorize. So for some of these, you might have to look up what they are, and that's fine. On a test, I might give you some additional ions than the ones that you have memorized. So here we go. Let's look. Let's look at the first example. So HNO2. So we know that H plus is the cation, so it must be NO2 minus that is the formula of the anion. Now this is not one you've learned, but this happens to be nitrite, and notice that it ends in ITE. That means that we follow this rule here. ITE changes to OUS, so this becomes nitrous acid. If we look at the next example, H3BO3. So it's got 3 H pluses in it. So this must be BO3 3 minus. That's not an ion you have learned yet, but you can look it up, and its name is borate. And so since it ends in ATE, we would change the suffix to ic. So that's going to be boric acid. Boric acid is actually a detergent. You may have used it at some point in your life, or your parents might have. Let's look at the next one. So this one does have an ion that we know. So H2CO3 contains the CO3 2 minus ion. That is carbonate. And the acid then, meaning this compound here, which is the acid, is carbonic. Acid. Again, looking at the fact that the anion ended in ATE, that means we changed the suffix to ic, and this is the name of carbonic acid. All right, one more in this list. HClO. So we know that it's an H plus, so it must be ClO minus, which is the anion. Again, this is not one you know. This is hypochlorite. Now remember, if we have an anion that ends in ITE, we change the suffix to OUS. Everything else we leave the same. So this is going to be hypochlorous acid. So in other words, this compound, which is the acid, has the name hypochlorous acid. Now before we go from moving from names to formulas, let's think about a couple of things. If the name contains the prefix hydro, what do we know about the anion? Well, that means we go to the naming rules on the previous page. So that means that the anion is going to be simple. If there is no hydro prefix and the suffix is ic, First of all, that means that the polyatomic ion was present, and whatever it is going to end in ATE. Likewise, if there's no hydro prefix and the suffix is OUS, that tells us it's a polyatomic ion that ended in ITE. Let's look at the first example here. Hypochlorous acid. So notice that there's no hydro, so that must mean that this is a polyatomic ion. And that means, and we take the OUS, and remember OUS goes back to ITE, so we know that that must be hypochlorite is the anion. This is not one you know, so you'd have to look it up. But once you know it's ClO minus, then you can write the formula as HClO. Let's look at the next one. Hydrofluoric acid. So the first thing we see is that it's got hydro in the beginning, and so that's going to tell us it's a simple anion. And the name of the simple anion that goes along with fluoro is going to be F minus for fluoride. Oh, I just switched this. Fluoride and the formula goes here. And so once we know that it's F minus, remember that an acid just uses H plus, so we're going to have to make the formula HF so that it's overall neutral. Let's look at the next one. The next one does not start with hydro, so that must mean that it's polyatomic. And the ending is OUS. So that must mean that this is sulfite. And that's not one you've learned, but you can look it up. It's SO3 2-, so it's a little bit related to sulfate, but it is not sulfate, it is sulfite. And we can see that it's got a 2- charge. So to make a neutral acid, we're going to make H2SO3. Now nitric acid might be one you've come across before. Notice that it does not have a hydro. It does have an ic. So this must mean it's a polyatomic ion that's in the acid. Ic means that it ended in ATE. And the nitra tells you it must be nitrate. This is one you do know, NO3-. And because it's a single minus charge on the polyatomic ion, then that becomes nitric acid. Let's look at the next one. Acetic acid. Remember, no hydro, but we do see an ic. So that must mean it's a polyatomic ion that ends in ATE. And in this case, it's acetate, which is C2H3O2-. This is one you know. It's a 1- charge overall. So the acid must be HC2H3O2. Now, somebody's going to ask me, could I just combine those hydrogens? You could, but we often write acetic acid in this way to signify that this is the H plus that got added to make it an acid. This is a different kind of hydrogen in the compound. Now finally, let's look at one last one. Notice the prefix hydro. That's going to tell us it's a simple anion in our acid. And we've got sulfuric, so that must mean that the simple anion is sulfide, which is S2-. It's got a 2- charge, so in order to make the acid, we're going to make H2S. So, let's just recap quickly. When we're naming acids, it's very important to know what kind of anion you have in the acid and to use the appropriate set of rules that are different for simple versus polyatomic ions.